Okay, so we'll start. First of all, I would like to make a short announcement for next month's webinar that will be held on October 24th. And the speaker will be Simon Eng. The title of the talk will be Lesson Learned from Forensic Investigation of Thunderstorm Hazards. He's from the Institute of Catastrophic Loss Reduction. So that will be on October 24th. So it is my pleasure today to announce Dr. Mark Serreze as the speaker of this month's webinar. Dr. Mark Serreze is the director of the National Snow and Ice Data Center, part of the Cooperative Institute for Research Environmental Sciences. While his
lost the sound.
Has a long-standing love for the Arctic. Interests include atmospheric sea ice interaction, synoptic climatology, boundary layer problems, and climate change. He has conducted field work in the Canadian Arctic on sea ice and ice caps, and on the Alaskan tundra. Efforts over the past 10 years have increasingly focused on trying to make sense of the rapid environmental changes being observed in the Arctic. So today's talk is titled Perspective on the Emerging New Arctic. Over to you.
All right. Well, thanks for having me. This is a real pleasure and an honor to be able to speak to you. I see a few familiar names out there. Growing up in Maine, I'm actually almost Canadian, so just remember that. But just to start this, perspectives on the changing Arctic.
Freezing.
I am I freezing? I'm sorry.
Yeah, okay.
Oh, maybe I need to just turn off my camera, right?
Oh, it seems to be okay, Mark. Please
oh,
proceed.
okay. I don't know what was going on. I have a good internet connection here. Any case, to start this out, well, probably a couple of years ago, I started to realize that maybe I've been in this business for too long in terms of Arctic research, because I look back and first time I went off into the Arctic was back in 1982. I guess maybe from some sense it's not that long ago, but it sure seems it. And this was work I was doing with the guy Ray Bradley, some of you may know him, on a couple of little ice caps up in northern Ellesmere Island, about 30 kilometers south of Alert. Probably some of you have been up there. And of course, that's the camp we had on these little ice caps flying the Canadian flag, of course. But what were we doing up there is that we were interested in these two little ice caps that were up there that I mentioned near the Hazen Plateau. And I show them there on the left. These were air photographs taken in 1959 by the RCAF. And what we were doing is we're testing how these two little ice caps were affecting the local climate by instrumenting them with what we thought were high-tech instruments at a time, Campbell Scientific Microloggers run with D-cell batteries. There I am on the right, looking a lot younger. But we would look at things like the temperature, radiation fluxes, albedo, all kinds of things on these little ice caps and compare them to the surrounding terrain, which was basically a very similar elevation. And looking at those differences, we could just see how those two little ice caps were affecting the climate. Where this came from was some thinking at the time, well, I guess it's still there, about how the last Laurentide ice sheet might have formed. We're through, say, a Milankovitch effect. We had cool northern hemisphere summers, and snowpack survived over like the Labrador Ongava Plateau. And so then it accumulated the next summer, didn't melt entirely, albedo feedback kicked in, and then eventually you have an ice sheet. That was the idea about it. And just trying to look at it from a very local scale and using these two ice caps in the surrounding terrain. Now, where this also came from was thinking at the time, some of you may remember, that there was discussion of a cooling climate at the time. And Giff Miller and Ray Bradley, who were both at Instar at the time here in Boulder, Colorado, they had this paper that they wrote. The climate warming trend since the 1880s seems to have given way since the 1940s to a cooling trend, most marked in higher latitudes. Well, that caused a bit of a stir, so of course some people picked up on it. They still do it today. Oh, you guys were saying that we might go into a new ice age or something. Now, clearly that didn't last. The one on the right from Time magazine, I put it in there as interest, okay, because it's actually a fake. Okay? It was put in there. I don't know who made this or made this cover or something like that. It's quite good, you know, talking about MASH, right? Remember that television series? But yeah, the coming ice age. Now, this was something that there were some scientists talking about this, and of course, the paper by Bradley and Miller was based on data, but this was really, really widespread. It was really promulgated by the media primarily, and as we know how the media works, it's just maximizing the drama. Well, they were doing it today, and they were doing it back then. Now, flash forward a few years, well, actually almost a decade, and I was doing some work out near Resolute Bay, out on Griffith Island, which was kind of 20 kilometers out on the sea ice. So we were camping out on Griffith Island, and then we would go out into the sea ice and do all kinds of measurements, looking at the thickness of the multi-year ice flows and things like that. Had some time to play, like playing golf, not bad form. I think there we would paint the golf balls orange and hit them around, and you take them out to the sea ice where there was bare ice. I mean, with a 9-iron, you could go hundreds of yards or so. You also had to have someone there with a shotgun because this was right in the middle of Polar Bear Alley. In any case, I was working with these students out of Canadian graduates. They were with Ellsworth Ledru's group. Some of you may remember that was at, well, he was in Toronto. I forget the university. I should know that, right? But it was a lot of fun, and we learned a lot about energy balances in the Arctic, radiation fluxes, things like that. There are, well, I don't like to say it, but there are stereotypes of Canadian grad students which are true, such as I quickly learned, do not go out drinking with them, right? That's a mistake. I won't repeat it again, but we had a lot of fun. Well, the thing is, back in those times, 91, 92, there was real question about where the climate was going. Okay, so despite, you know, that 60s cooling that Ray Bradley had been talking about and Giff Miller, there was recognition, growing acceptance that the climate was eventually going to warm, especially in the Arctic. Sort of the idea of this Arctic amplification. But that first IPCC report came out in 1990. The evidence for Arctic warming was kind of spotty. And if you look at the temperature trends, say from 79 through the early 1990s, with one of the reanalyses I think we used here, the probably the era 40 reanalysis, it was clear that the Arctic, well, of course, I did this figure later, but the Arctic was seen to be warming in some areas, but cooling in others. And that was pretty much consistent with plain old natural climate variability. So this figure here is showing temperature trends over that period. It's like, I think it was like 79 through 93 or something like that we put together. And you look at that pattern and you say, well, the warming in some areas, cooling in others. So you have North America on the left side, Eurasia on the right side. And you look at that, you know, warming over Eurasia, cooling over the area around Greenland. That looked just like our old friend, the North Atlantic Oscillation. And in fact, what was happening is there was a period going through about the mid-1990s from, say, 1980s, when the winter NAO was kind of trending towards a positive phase. It kind of, you know, went up into this, it was not a consistent thing, but it was overall positive. And so that overall trend in that NAO at the time is consistent with the picture that you see here. this pattern of warming and this pattern of cooling. So looking at it and say, well, no, we don't need to invoke the specter of the satanic gases or whatever you want to call them, right? You can think of this as just internal climate variability. Now, there was also then the 1992, which was the second year I was up near Resolute Bay with these Canadian grad students. And that was just after Mount Pinatubo had blown. The spring of 92, we were up there. It went off in 91. And it was basically a year without a summer up there. You never really had a summer melt process going on that year. Oh, there was some melt, of course, but it really never took place. It was kind of a year without a summer. And so this kind of just put more of these ideas in my mind that we're not really seeing what the climate models were saying were going on. Now, we've, of course, learned a lot about the effects of volcanic eruptions since then, but it was an interesting summer up there. This is just a picture of, this would have been probably in June, I think, during one of the blizzards that we had up there. Then we published a paper in 1993 in Nature. And this was based on looking at the radiosonde data, looking low level and then upper air from the radiosonde network that we had at the time in 1993. And I was a co-author on that. And this was our conclusion, that we do not observe the large surface warming trends predicted by models. And indeed, we detect significant cooling trends over the Western Arctic Ocean during winter and autumn. So in other words, where is the warming? Now I'll stop here and make sure that I'm still alive and everything is working, right? You can hear me and I'm not freezing. Is that correct?
Yeah, so far so good.
Good. All right, just wanted to check. Okay. Well, what were the views within the science community at this time? Well, you talked to Jim Overland of NOAA. Some of you probably know him. He's been at NOAA forever. He's been there longer than I've been doing Arctic stuff. He'd been doing Arctic climate research since the 1970s. And this was sort of the views of where things were back in the early 90s. And he says in 91, 92, we did not see or think much about Arctic changes. It was all about variability. Here's Marika Holland, a well-known climate modeler at NCAR. At the time, she was just embarking on her career. And she says she wasn't thinking too much about Arctic change, that it seemed like something far off and far away. So that was kind of some of the views that you were seeing in the Arctic community about what was happening at the time. But even around then, there were these hints of change going on. And one of them related to what was happening to the Arctic Ocean. Detlef Kodfassel, okay, a German oceanographer, he was part of the cruise of the Russian icebreaker Rossiya in 1991. There it is on the right. And he noted this slight warming of the Arctic Ocean's Atlantic layer. And the data was sparse, and he admitted that it was sparse, but it was intriguing, just intriguing evidence that maybe the Arctic is beginning to stir. That was the idea. That was what he was saying. And then other evidence started to come through. So this was from a study by Drew Rothrock at the University of Washington. And what he was interested in is Arctic sea ice thickness, or draft. Draft is the part of course, an ice flow that sticks underneath the water, roughly 90% of it. Of course, it depends on the snow on top and things like that. But he did this analysis from submarine sonar data. Started with the Nautilus, of course, and that was one of the early records. Nautilus was the first, of course, nuclear submarine. And at the time, there was work to declassify some data, and there was actually Russian collaboration on these sorts of things to try and get some of this draft data. And the results he got were pretty striking at the time. So he compared these data that he collected, that were collected, I should say, he didn't collect them, 1958 to 76, the early records, with what he got from the more recent data, 93, 97. And here were these results comparing the two, and it was showing in all these sectors, Beaufort Sea, Canada Basin, North Pole region, Nansen Basin, etc., that there had been significant or substantial, I'm not sure, what the statistical tests were here, but a substantial decline in ice draft, which means a substantial thinning of the ice. Well, what did this say, right? Well, things clearly seem to be changing. How would we lose that ice draft? How would the ice become thinner? All right, some of it could be you're advecting the thick ice out of the Arctic Ocean, but apparently the Arctic Ocean was starting to warm. And it looked like part of this might be that the ice is starting to get hurt from above. In other words, more summer melt, less winter ice growth. So the evidence for a changing Arctic was really starting to strengthen now, was starting to gel. Okay? But I still wasn't convinced. Actually, it is in people. I mean, if you look on the internet, there are certain sites or certain people that do not speak fondly of me. Okay, I get that. No problem. Okay. But the reality is that around the turn of the century, that's the 21st century, of course, I was kind of a fence sitter on this, a bit of a skeptic. And my skepticism was not about whether we would see the changes that were projected. The issue was whether we had seen them yet, right? And I still wasn't really convinced. And so in the year 2000, I led this paper with a bunch of co-authors. There's probably a number of familiar names in here, like John Walsh and Tom Osterkamp, who's a permafrost guy, Vladimir Romanovsky, Jamie Morrison, well-known oceanographer, and others, and my old advisor, Roger Berry. And what we did was we assembled all of the time series we could find, all of the evidence of what could be changing in the Arctic, and try to synthesize it all. And this was the conclusion that we had, this paper published in the year 2000, that taken together, these results, that was the results of the synthesis of all this data, that the results paint a reasonably coherent picture of change, but their interpretation as signals of enhanced greenhouse warming is open to debate. Right? It still wasn't clear, at least to our minds. That's not to say that others were not saying this. Others were saying, gung-ho, things are changing, the Arctic is rapidly changing. There were a bunch of initiatives put together, like the it was the surface heat budget of the Arctic program that took place in 97. And then National Science Foundation, the funding agency down here, was trying to put together this big project for the study of Arctic change. But, the evidence was still kind of a little spotty, in my view. But then that changed. That changed with a bunch of, I would say, rude awakenings. My view, I'm looking back on this, and it was probably around the year 2003, 2004, maybe about that I was in the position of saying, okay, here we are, right? It's clear now the Arctic is warming, the Arctic is stirring, the Arctic is changing. And there's a lot of pieces to the evidence of that. For example, that the sea ice trends were really firming up. The warming patterns that were some areas warming, right? Some areas cooling. It turned out to be a general warming. And I remember telling myself that, well, if the NAO, which seemed to be giving that pattern in the past, kind of drops to a more neutral phase and we still see the warming continue, that would be something that would convince me. And that's exactly what happened, right? This is just a nice little picture from the North Slope of Alaska from some work we were doing on energy balances and snow. So we had this circular thing where we are measuring snow depths and densities, kind of a little pinwheel thing. A lot of fun being out there. But what are some of the things that happened? Well, one of the rude awakenings was what happened in 2007 to the sea ice cover. We had been losing sea ice. The trend was firming up. We saw that there were downward trends in all months, but especially pronounced at the end of the melt season in September. And then, all right, 2007 comes along, and it was amazing to look at that the ice just kept getting eaten up and eaten up during summer. People were going to our website because at this point we were doing this daily monitoring that people could take a look at. Going to it like the baseball box scores or something like that, back when people looked at baseball box scores every day in the summer to see what was happening. And the previous minimum had been in 2005. That had been the previous record minimum. You see that in the green line. And 2007 came along and just blew that record away, just blew it out of the water. You see in the yellow there, that's the median extent over the period then when we analyzed it of 1979 through 2000. So it was really amazing. Now we knew that that minimum, that a lot of it, that what was going on was that there was an atmospheric circulation pattern that's set up that was really ideal for getting rid of ice. You had pretty strong high pressure over the Beaufort Sea high, low pressure to the west over eastern Eurasia. And so you basically had a pretty good egg beater effect there, that you had very strong, warm, persistent warm winds coming out of the south that just ate up the ice on that side of the Arctic that you see there. But nevertheless, even though we know it was boosted that way, it was really the eye opener that things were really changing. We've subsequently learned a lot, of course, about the relationship between sea ice anomalies, what you get in September, and weather patterns, right? You have a favorable weather pattern to get rid of ice in summer, an unfavorable weather pattern. We just passed the seasonal sea ice minimum just a little while ago. We keep track of this. Turned out seventh lowest, right? Did not set up a new record. Why? Well, the weather patterns weren't all that favorable this year, but we still got to number 7. Any case, this was one of the events that was really an eye opener, and to many in the community that, wow, is a new Arctic upon us or emerging? Well, lots of other things were going on too. And one of them was a recognition of warming and thawing permafrost across a lot of the Arctic. Here's a couple of shots from Alaska, where the ice in the permafrost melted out, and you get these, pretty big changes in the landscape with the land just slumped, and we had, tremendous changes. If you look on the big photograph, this actually, you can barely see it, but there's someone there for scale. But there's a road near Fairbanks that slumped down to the permafrost thaw. If anyone driving around now, around Fairbanks, it's just bumpity bump because of all the thawing permafrost. So there was a recognition that this was happening, and of course, the Arctic landscape is very much defined by its permafrost, right? The perennially frozen ice. Now we start to see it warming and thawing, and start to see things like this happening. Related, thawing permafrost and coastal erosion became recognized that this was a growing problem. That there are some areas, even today, well, still today, along the Beaufort Sea coast of Alaska, retreating 15 to 25 feet per year. So what's happening here is kind of a triple whammy, actually, is that there used to be ice there in summer, sea ice there in summer, and that limited the wave action. Well, now you go out and you might not see sea ice for hundreds of miles. Now this shot was taken before earlier in the year. You still see some ice there, but that meant that the winds had a big fetch over open water, and you get big waves. So you would get erosion from that, mechanical erosion. But at the same time, these coastal bluffs, that's permafrost is the glue that holds them together. And so the waters were warmer as well, so you start to get thermal erosion. But the permafrost itself was warming, and that helped. So you kind of got a triple whammy going in here. And this is how it would work. It would the waves would kind of under notch those coastal bluffs, then you get that slumping like that. You've probably all heard about Shishmaref Island and places like that, right, where the erosion has become a real big issue. Warming and wildfire. there is evidence growing, right, of increased wildfire activity in the boreal forest, even tundra, partly apparently due to more convective activity and lightning, because most of these are lightning caused. This was from some work we were doing near. This was a little north of Fort Providence, in Canada, which is subarctic, and we were looking at permafrost characteristics in this area. That's a ground penetrating radar. You see that thing with the white handles, a ground penetrating radar. There was very little permafrost here. One of the reasons we wanted to look here was because it was a burn site. And so you can see what had happened to the black spruce and like that. And this is of interest, is what happens when you have wildfire and how does that affect the permafrost underneath. We did not find much permafrost here, very, very, very little. If you look at the permafrost maps, they're saying that this is a region of, that there should be some permafrost here. And it was maybe one or two places where we had found any. So the maps are wrong or things have changed, right? But this was a really fun study that I was involved with, looking at these sorts of things. But what else is going on? Big changes. All right, melting Greenland ice sheet. Well, here's just an image of one of these meltwater channels that is flowing off of Greenland. It looks very cold. You probably do not want to fall into that, although I have heard that people will try and take their kayaks down these sorts of things, which seems foolish to me. You don't want to fall down a Moulin or something like that. But yeah, this is clearly way down in the ablation zone. But yeah, the Greenland ice sheet, as we know, is losing mass. Now, this is a record on the right from GRACE and GRACE FO. Some of you may have used these data. It's a gravimetric measurement system where you got two satellites, one in front of the other, separated, I think, like 300 kilometers or so. And it measures gravitational anomalies. So when the first satellite goes over a gravitational anomaly, a positive anomaly, it'll speed up because an orbit is just a free fall. So then it passes that anomaly, and then the satellite in the back passes over the anomaly. So the distances between the two satellites change. And using this information in very complex ways, one can map gravity anomalies across the Earth. Through repeat coverage, one can see what changes are occurring. So GRACE started in 2000, it died, and then GRACE FO came on, which was a newer instrument because GRACE had proven to be so successful. And yeah, you are losing mass. You see those ups and downs all through the time series. That's just the seasonality that in the autumn and winter, the ice sheet gains mass, and through the spring and summer, there's melt, things like that. Now, of course, there's always icebergs being discharged. On the left is just showing the ice speed of the glacier, which can be determined from remote sensing. The reds are where the ice speeds are high. And so, of course, you see them in the big drainage glacier areas, but there's evidence that some of these glaciers are speeding up through various reasons, through thinning, which reduces the back pressure, through meltwater being discharged out of the base of the glacier. Some of you remember the Zwolle effect, okay, although people have known about this for a long time. A lot of things going on. It's still being figured out. But Greenland is definitely losing mass, and it has been for some time, and contributing to sea level. Now, it goes further than that. I didn't put that in there. I thought I had put in another one about glaciers across the Arctic that are not in Greenland, also showing the same sort of thing. They're retreating, they're losing mass. But now, go back to those ice caps that I studied. Way back starting in 1982. Well, here are outlines of those ice caps. And you can see what happened. Now, 1959, that's the outline from these aerial photographs. And that was RCAF, taken back then. Now, Ray Bradley, he was my old advisor. So if his students went back in 2001 and used GPS to get the outlines then, and you see how it really shrank. Well, we got interested in this and got a hold of some high resolution satellite imagery. I think it was Aster data that we were using. And we got outlines for 2014, 2015. And you can see what was happening to those ice caps. By the end of 2015, or the end of the melt season, this of course was summer, so these shots were probably taken probably mid-August, I'd guess. They'd lost something like 95% of their area. So they'd really shrunken. And now they're gone. Now they're gone. So I cropped the one on the right from those aerial photographs that shows our old stations. And I tried my best to match it with the area from a recent shot. This was just a couple of years ago. Completely gone. Absolutely nothing left. You can see kind of the outline of where the thing was on the satellite image on the left, but absolutely completely gone. And so this was something that really made this whole issue of a changing Arctic personal at this point. My ice caps had disappeared. Well, they were the Canadian government's ice caps at the time. Of course, now that this whole area is part of Nunavut. But I kind of took it personal. Now, these ice caps, from what we could tell, they were little ice age features that they had formed during the little ice age. And even in 1982, you can see on the right that they were shrinking. You could see those dirt layers and things like that. So they probably would have disappeared at some point anyhow. But it just struck me that you think of an ice cap like that. These were little things, like the big one was 6 kilometers across at its widest. It wasn't very big. Seemed like such a permanent part of the landscape, and to realize that it's not, right, was quite the thing. So we actually wrote a paper on this, on the shrinkage of these two little ice caps, and we had a post at NSIDC on their eventual demise, right? So, but this kind of made things personal to me. And really over the past, I would say decade, I've kind of shifted from just looking at the physics of the problems, why are we losing the sea ice and this sort of stuff, to more of the impact, right? Coastal erosion, I just mentioned. Okay, what's happening to the permafrost and what are the impacts of losing that permafrost? One of them being, of course, the old permafrost carbon feedback issue, that there's a lot of carbon locked up in these frozen permafrost areas. You warm and thaw that permafrost. Now the microbes in the soil become active. What do? They eat the carbon and they release carbon dioxide or methane. Right? When will that kick in? And how big will that be in terms of increasing the carbon load to the atmosphere? Greenland, of course, the impacts of sea level rise. Rain on snow, that is a project that I've been involved with for several years now, almost 5 years now, where the issue of what happens when you have a rainfall on top of an existing snowpack and then it freezes up again, like a cold front comes through and it freezes up again. And it is increasingly recognized that these events can have severe impacts on wildlife, because what happens is you get ice layers in the snow or icy crusts, and so the reindeer and the caribou can't forage. And there have been issues of like 30,000 reindeer at a pop dying because of starvation, which can either be immediate or it can go through generations because it influences calving success, things like that. There was a case out in Banks Island, Western Canadian Arctic, where something like 20,000 muskox died after one of these events. So we've been studying these a lot, the meteorology of them, of course, and how they were linked with things like atmospheric river events, but then very, very much on the impact on the wildlife and how they're affecting reindeer herding practices, things like that. So a big issue as well. And of course, the impacts on the ocean. All right, so phytoplankton blooms. So there's less ice, ice is thinner, ice retreats. phytoplankton blooms. What does that mean? Is it nutrient limited? I'm not an expert on that, but it's a big change. Now, of course, there's the whole polar bear issue, right? And you know, the iconic image of a polar bear on a melting ice floe. And my understanding of this, working with some of the polar bear people, is some populations are definitely in trouble. Some seem to be doing okay. The concern is that what will be happening in the future, because they are an ice-dependent species, right? They hunt off the ice. That's where they like to spend their time. And when there's no ice or it's hard to get out in the ice, that's a problem, right? I mean, okay, people go up to Churchill, right, to see the polar bears, and they're all out on the shore. Well, there's no ice, right? So they can't get out there. Other ice-dependent species like walrus, all right, which like to hunt off the ice and go down and get clams and things like that. But now in summer, the ice retreats beyond the continental shelf. And so now they got a problem. So what happens? There is some evolution or some adaptability here. They can haul out on land. You may have heard these stories about Point Lay, Alaska, where the walrus are hunting out, are hanging out, and how you really have to be careful in not to cause a walrus stampede or something like that. There's a lot going on. And of course, it goes, you know, way beyond that. Fisheries, things like that. Now you're starting to see things like Alaska pollock move up into the Chukchi Sea, where you didn't really used to see them before because there's less ice. So there's lots happening. Now, weather-wise or climate-wise, there's these issues, of course, that have emerged. Can Arctic warming influence weather patterns beyond the Arctic? Basically by influencing the jet stream. There's all kinds of different ideas out there, but you know, the simplest way that I look at it, and I'm sure it's way too simple, is that by strongly warming the Arctic, which we are, that whole issue of Arctic amplification, that this means that we're changing the equatorial or the meridional temperature gradient, and the jet stream is going to respond to that. So more waviness in the jet stream, et cetera, et cetera, et cetera. There's a lot of stratospheric arguments out there. It's not something that I've really kept up on because I have, you know, other things going on, and my dynamics is probably just not strong enough to look at this kind of stuff. But it's controversial. I mean, from my read of the literature on this, there's some people saying absolutely this is already happening. We're getting into these stuck weather patterns, things like that, very wavy jet stream patterns. And there's others who are saying, well, there's really not much going on there. So my understanding, and I could be wrong here, someone could correct me, is that, well, it's accepted that the warming Arctic is having some influence. It's unclear how strong that influence is compared with things like, you know, tropical sea surface temperatures and the like. But it's a wild card out there. It's a real wild card out there. Will the Arctic warming result in things like this? There are still puzzles, I would say. If you look at the climate models and what they're saying, they are saying that Arctic precipitation should increase. The Arctic should become wetter in this sense, because we have an atmosphere now that can carry more water vapor because it's warmer, but that is also meaning that there's going to be increased water vapor transport from the south, increased advection. So provided that you have uplift mechanisms, and there seems to be no shortage of those, Arctic precipitation will increase. All right. Well, have we seen that yet? And the answer is maybe squint your eyes. All right. This was from the NOAA Arctic report card in 2023. There's also the very similar Arctic section of the State of the Climate in the AMS, which draws from this. And so this was what we found last year with a time series through 2023. We're looking at a water year here. And you look at winter, maybe a little bit, in the annual, yes, a little increase. It passes the statistical tests. But, you know, is it really increasing? I'm not sure yet. I'm not sure yet. But this is a case where in some issues, such as the whole Arctic amplification issue, projected that the Arctic would warm especially strongly compared to the rest of the planet. Absolutely, we've seen that, right? But as far as some other things like precipitation, is the signal still emerging? Yeah, we will see what happens. And of course, as I think we all know, I've worked with a bunch of people in Canada on this, that Arctic precipitation is notoriously hard to measure. We don't have the station data. We have big problems with gauge undercatch and all that. So we will see what happens. But there's a whole other element happening now. Arctic change and the whole geopolitical scene. So it's kind of a chess game now. Or is it a game of risk? I don't know. This is, of course, showing it as a game of risk. Okay? What is happening up there? There are tensions. There are growing tensions. So here's a Russian Tu-95, a Tupolev Tu-95, or it's the Marine version or whatnot. And there's being escorted by F-35 or F-22. I can never quite tell the difference sometimes. But yeah, Russia probing defenses in Canada, okay, in Norway, various places like that, because Russia very much wants to dominate the Arctic. Russia always has very much dominated the Arctic. They've got a huge Arctic coastline. They've been operating on the Northern Sea Route for a long time. Now that Northern Sea Route is more accessible. A lot of reasons out here. New air bases being built, or old air bases now being refurbished. Nagaskoye, probably got the pronunciation right, Franz Josef Land, way up there. Franz Josef Land, well north of 80 degrees. Look at that. We have very, very modern facility. Very, very modern facility. You see that in the US, I'm sure it's the same in Canada, that we see the Department of Defense really becoming interested in the changing Arctic. So you see the Department of the Air Force with their Arctic strategy, the United States Army regaining Arctic dominance, although it's not clear that they ever had Arctic dominance, but I guess they want to regain it. The Department of the Navy, okay, a blue Arctic, all these concerns. You've got an Arctic now which has less ice, it's more accessible. And so what does that mean? A busier Arctic. Well, the Department of Defense, of course, is very interested in this, and there are concerns that are growing because of geopolitical tensions, which have not abated as far as I can see. It has to do with a lot of different things. Oil and gas development. So here are basically license areas along the Russian coast. This is all within their EEZ, their exclusive economic zone, so they can do whatever they want. But there's a lot there, and as I think we all know, Russia's going gung-ho on gas production and shipping it out to European markets, increasingly to Asian markets. And they've got now these LNG carriers, ice-strengthened or ice-breaking LNG carriers that can go through like a meter of ice. And of course, with milder ice conditions in the Northern Sea Route, they can operate for most of the year. So there's a lot of this development going on. And of course, Russia naturally wants to protect those resources. But it's going on elsewhere, like Norway, right, as a big producer of, well, actually, it's not a big producer. It's something like, it's like 2.6 million a day, something like that. But it's very good oil, nice light crude. But doing a lot of operations up there in the Norwegian Sea, but also now moving into the Barents Sea, okay? But as part of their EEZ. All production from Norway all of it is offshore. Every bit of it is offshore. In Russia, of course, it's offshore and onshore. What about in the US? What's going on? There's, of course, all of these concerns about, well, this oil in the National Petroleum Reserve on the left and the Arctic National Wildlife Refuge. All these controversial issues about drilling there, the 1002 area that relates to the porcupine caribou herd. And of course, in Canada, of course, you're producing in the Alberta tar sands, right, which is just a different issue, very heavy bitumen, essentially. In the U.S., there's not as much really going on in the Arctic. There's talk, okay, the Willow Creek project starting up, but you hear our Lisa Murkowski, she's the Alaska senator, talking all about Arctic production and things like that in Alaska. But the heyday of Arctic production in the U.S. is well past its heyday. Fisheries, I mentioned this, that there are now is Alaska pollock in the Chukchi Sea. It's my understanding that Russia was going to open up an Alaska pollock fishery in the Chukchi Sea. I don't know if it's actually happened or not. I need to catch up on that. But there's Alaska pollock, not an especially impressive fish. If you have the horrible breaded fish sticks that you can get from the store and put in the oven, they are likely to be Alaska pollock, horrible fish sticks. In any case, then this issue of shipping, right? The northern sea route along the Russian coast, which you see there, the new Suez Canal, right? There is talk about that. The answer is very unlikely, very unlikely. Although Russia is gearing up towards a busy Arctic. Remember, Russia's been operating on the northern sea route for a long time. Let's talk about new Suez. Very unlikely, unless something happens. For example, remember that Evergreen International ship that got stuck in the Suez Canal. All right, blocked traffic for a while. But what if there was something like a terrorist attack? They sink some ships in the Suez Canal. Of course, that happened a long time ago. Then maybe an Arctic route becomes more sensible. We'll see. Of course, the Panama Canal, there's new locks in there, which can handle much larger ships. Okay? But what if something happens there? Does an Arctic route become more tenable? And the timing of this is important because right now, any route along the Northern Sea Route is either in Russia's territorial waters or along in their EEZ. But by the year 2030, something like that, is that no longer the case? You just go right across the Arctic. The Northwest Passage, even less likely. These are treacherous waters, right? There's draft issues. Sea ice can drift into these channels very quickly. Okay, you remember things like the Crystal Serenity that went through there some years ago. But as a viable commercial shipping route, I just don't see it. And I don't think a lot of people do. But yeah, Russia definitely wants to flex its muscles. They, of course, have the most capable nuclear icebreaker fleet in the world, the most capable icebreaker fleet in the world, including a lot of nuclear ones and new ones, right? The new Arctica. There's several new icebreakers that Russia has built and continues to build, which can go through anything. And so if you're going to operate along the Northern Sea Route, for example, you've got to have year-round access and all that. So you do need icebreaker capability, even in a warming Arctic. And of course, in the U.S., we've got next to nothing. Oh, they finally fixed the Amundsen. They had a fire in the engine room. I know in Canada, you've got the Amundsen, which is, medium-sized, used a lot for research, but we don't have anything like this. The U.S. is trying to build new icebreakers, but is way behind schedule. There's issues of who owns the Arctic seafloor. All right. This goes back to the United Nations Convention Law of the Sea and territorial seas extending out from the internal waters by 10 nautical miles, and then the EEZ. And the country that has that EEZ has the rights to all economic activity within it. But Russia has made claims, right, that through extension of the Lomonosov Ridge, which they see as an extension of their continental shelf, they can claim more of the Arctic seafloor. Now, this is something that goes through the courts. I don't know how it works and like that. It's been going there for a long time, but you see, these are the sort of things that are happening up there. There is the Arctic Council, which fosters cooperation, coordination, interaction between Arctic states. And of course, Canada is part of the Arctic Council because you've got a lot of Arctic territory. So is the US, but Russia is no longer part of the Arctic Council. Their activities have been suspended. And this relates to the Russian invasion of Ukraine. And this is not a good thing, because if you really want to sustainably develop the Arctic, have a recognition of indigenous rights, all that stuff, you need to have that coordination going on. So there's not that much going on, my understanding, with the Arctic Council right now. I may have that wrong, but the whole situation with the Russian invasion of Ukraine really threw a wrench in the works. So just ending here, right? The Arctic is really changing. We know that now. We have for a while. The planet keeps on warming, and the Arctic is definitely leading the way. This is map of temperature changes from the NASA GISS analysis, 79 to 2023 annual. And you can see that Arctic amplification, that strong warming of the Arctic. And of course, that then cascades through so many things. You're warming, you're losing, so you're losing the sea ice. You're losing the sea ice, so you enhance the warming. And then that comes with all these other impacts on things like permafrost, ice-dependent species, accessibility of the Arctic, right? But, you know, it's a small planet, and so we're going to have to work out some of these problems. So with that, hopefully you're still with me, and questions. So I'll stop sharing here, see if you're still there. And
Yeah, everyone is here.
Good. So let me
So
I
open
thought
it
I'd
up for
stopped
questions.
sharing. Oh, yeah, questions. I thought I'd stopped sharing. Whoop. Okay, here we go. Yes, questions. It's always hard on these Zooms, right? Don't quite know so what's going on.
Okay, and don't see any hands up or, oh, wait a minute, there's one in chat.
Okay.
He said, sounds good to me. Mike Brady. Okay.
Yeah, that was earlier in the call when Mark was just making sure that he was being well heard.
Okay. Yeah.
I actually
You never
do
know
have
with all this technology, what's going to happen.
I actually do have a question if you don't mind.
Sure.
Would you say that there's an opportunity with the increased interest from defense to get additional funding to improve the science?
I think so. This is something that we've been discussing in our group. And you think there should be a natural connection between issues of defense and like that and the scientific community, because there is so much that can be learned. In the US, there's inroads there. For example, it was about a year ago, I was invited down to the Army War College in Pennsylvania because they wanted to talk about the changing Arctic and the things that were happening and wanted to know what the scientists were saying. They want that collaboration. This idea that the Department of Defense in the US is all, oh, climate change is nothing. It's just some kind of fake news or anything. No, absolutely not. They're very much pragmatist and see what is happening. So there's a natural connection there. But as you probably know, it can be very hard for academics to want to go in this direction, right? It's kind of not what we do. We want, some will get involved in this, some will not. So I see that as the bigger issue right now. My view is that Department of Defense wants that input. But the challenge is in getting the community on board to find those connections. That's just my own opinion and view.
Right. Thanks very much for the talk. It was very entertaining.
Good. Not as much meteorology. I could have put more meteorology in it.
Okay, any other questions?
Right.
Okay, well, I will ask you one question, and that is, what about this geoengineering, of putting water on top of the ice to thicken it so that it won't melt so quickly in the summertime?
I think geoengineering is a fool's game. That's just my truth. It's a fool's game. We have this dial of climate change, right? And now we're going to play with this dial that says geoengineering. Oh my gosh, right? You get a lot of these ideas out there. Pump seawater on the top of the Antarctic ice sheet to reduce sea level. Well, of course, what are you going to run your pumps on, right? This energy conservation. I think if we ever have to go to a geoengineering approach to things, oh man, we'd have to be in pretty bad shape. You know, I see geoengineering as simply a band-aid that does not address the bigger issues. The bigger issues, the primary issues need to be addressed. Do we have to go there someday? Maybe so, but it's probably not a planet I would want to be on. That's just my view.
Okay. All right. Any other questions?
All right. Well, now I got a talk coming up from one of my former students. I got to set that one up. So it's a day of seminars for me.
Okay.
Thanks,
Well,
everyone. Really appreciate it. Bye-bye.
Thank you very much, and taking us all the way from 70s to the current time and how
Yeah,
Arctic has evolved.
things have
So thank you
evolved.
very much for that background.
Okay,
Uh,
sure enough. Bye-bye.
Right.